A superhabitable planet is a world that might have an even better chance at hosting life than our own home, Earth. Because Earth is the only known inhabited planet, and its life depends on liquid water, efforts to identify exoplanets that could host life focus on Earth-like worlds. But some researchers think there are other types of planets that could offer conditions for life as good as, or even better than, Earth. In fact, some scientists argue that focusing only on Earth-like worlds might be too anthropocentric and geocentric, blinding us to the possibilities of exobiology. We are so over-focused on finding a mirror image of Earth that we may overlook a planet that is even more well-suited for life. Dirk Schulze-Makuch, an astrobiologist at Washington State University and the Technical University of Berlin, told. To search for potentially superhabitable exoplanets, Schulze-Makuch and his team investigated the Kepler Object of Interest Exoplanet Archive, focusing on 4,500 planetary systems that likely possessed rocky planets within their stars' habitable zones, where liquid water can persist. The researchers published their findings in a 2020 paper in the journal Astrobiology. In addition to looking at planetary systems with yellow dwarf stars like our Sun, the scientists also looked at orange dwarf stars, which are cooler, dimmer, and less massive than our Sun. Our Sun is actually not the best kind of star for hosting a planet with lots of life on it, Schulze-Makuch told. Orange dwarf stars are about 50% more common than yellow dwarfs in the Milky Way. Whereas our Sun has a lifetime estimated at less than 10 billion years, orange dwarfs have lifetimes of 20 billion to 70 billion years. Since complex life took about 3.5 billion years to appear on Earth, the longer lifetimes of orange dwarf stars could give planets within their habitable zones more time to develop life and accrue biodiversity. Earth is about 4.5 billion years old, so the researchers speculated the sweet spot for life would be a planet between 5 billion to 8 billion years old. The size and mass of a planet can also influence how well it can support life, the researchers wrote. A rocky planet that is larger than Earth would have more habitable surface area and potentially a thicker, more stable atmosphere. A planet with about 1.5 times Earth's mass would likely retain its interior heat longer, which in turn would help keep its core molten and its protective magnetic field active for a greater time span in which life might have the chance to arise and evolve. Worlds that are slightly warmer than Earth by about 8 degrees Fahrenheit, 5 degrees Celsius, might be superhabitable, since they could have larger tropical zones which on Earth foster more biodiversity. However, warmer planets might also need more moisture, since greater heat could expand deserts. In addition, planets with the same amount of land area as Earth, but broken up into smaller continents, might be more habitable. When continents become particularly large, such as Earth's past continent Gondwana, about 500 million years ago, their centers are far from oceans, often rendering the interiors of large continents vast, inhospitable deserts. Moreover, Earth's shallow waters have a greater biodiversity than its deep oceans, so scientists speculate that planets with shallower waters could support more life. What are some superhabitable planets? All in all, Schulze-Makuch and team identified 24 potentially superhabitable planets. None of these worlds met all the criteria the researchers drew up for superhabitable planets, but one did meet at least two, KOI 5715.01. KOI, Kepler, Object of Interest. 5725.01 is a planet about 5.5 billion years old and 1.8 to 2.4 times Earth's diameter, orbiting an orange dwarf about 2,965 light-years away. It might have an average surface temperature about 4.3 degrees F, 2.4 degrees C, cooler than that of Earth. But if it has more greenhouse gases than Earth to trap heat, it might be superhabitable. Schulze-Makuch's own favorite potentially superhabitable world from these 24 was KOI 5554.01. This planet is about 6.5 billion years old, with a diameter 0.72 to 1.29 times that of Earth, orbiting a yellow dwarf about 700 light-years from Earth. I really like the average surface temperature, about 27 degrees C, 80 degrees F, Schulze-Makuch said. And it's probably about Earth size, and a little bit older than Earth. All 24 of these potentially superhabitable planets are more than 100 light-years from Earth. This makes them too far for NASA's Transiting Exoplanet Survey satellite, TESS spacecraft, to capture high-quality images from to learn more about them. Still, Schulze-McCouch noted that future spacecraft, such as the James Webb Space Telescope, NASA's LUVOIR Space Observatory mission concept, and the European Space Agency's Plato Space Telescope, could shed light on these worlds. So if we are to look for a world more habitable than Earth, we need to find a place with even more biomass and biodiversity, and we propose a number of ways they could come to exist. One way is to replace our yellow dwarf G-class star, the Sun, with a K-class star, or orange dwarf. K-stars would offer a radiation environment that's less harsh, especially in the ultraviolet and X-ray spectra. K-class stars also live longer, 15 billion years or more, providing more opportunity for planets to give rise to life and sustain it. Earth, on the other hand, will become uninhabitable for humans in about 1 billion years, and it might cease to exist altogether when our Sun becomes a red giant a few billion years later. We also might look for certain environmental parameters that would improve the habitability of a planet. Without its atmosphere, magnetic field, and plate tectonics to recycle the crust, Earth might not have such a large global biosphere. Yet things could have been better. Our planet has gone through extreme climatic swings. During so-called snowball Earth events, most of the planet was glaciated and covered by ice, which reduced biomass and biodiversity. During the Carboniferous period, though, about 300 million years ago, large rainforests and swamps covered much of Earth, and oxygen levels were so high that giant insects with huge wingspans were buzzing around. Earth was in ways even more habitable than it is today. Therefore, when we talk about the habitability of Earth, and this is an important point, we need to specify when in our geologic history we mean. Just what kind of environmental factors would make a planet more habitable than Earth? This gets a bit tricky. Much depends on the specific habitats and how fragmented they are, and not every location on even the lushest planet will be suitable for life. Rainforests, for example, will have more biodiversity than deserts, whether they are cold Arctic deserts or warm ones like the Sahara. Coastal areas are richer in biomass than the open ocean or dry inland areas. Thus, the distribution of land and ocean will make a difference. Ideally, you want as many coastal areas close to sea level as you can get to increase the habitability of a planet. How about a rocky planet more massive than ours, a so-called super-Earth? Is bigger better when it comes to habitability? Well, it depends. If the planet is just a little bigger than Earth, that may indeed be beneficial, as the larger surface area should translate to more biomass and biodiversity. And the greater gravity should produce a thicker atmosphere, encouraging the evolution of flight and expediting life's spread to all parts of the globe. However, we have to be careful here. If our telescopes spot some distant planet that appears to be the right size, it may turn out to be a gaseous mini-Neptune instead of a super-Earth. Nobody knows at present where the size cutoff is, and some scientists speculate that it may be when a planet is merely 50% more massive than Earth. How about age as a habitability factor? We might think an older planet would be more life-friendly because on our own world, biomass and biodiversity generally have increased with time, aside from some mass extinctions and adverse climatic swings. But Earth may be an exception. The longer a planet exists, the higher the likelihood the life on it could be destroyed by cosmic mayhem, such as a huge asteroid impact or supernova explosion. Or it may just run out of steam, that is, the internal radiogenic energy source critical to sustaining a magnetic field and driving plate tectonics. A more habitable planet might resemble Earth in the early Carboniferous, about 359 million years ago, when much of the world's landmass had the climate of a tropical rainforest. Modern-day warming isn't good for life on Earth, both because the change is happening too quickly for many animals to adapt, and because of the effects on human infrastructure due to rising sea levels. Slightly warmer temperatures, however, aren't inherently bad for life. The perfect planet would also have plate tectonics, or a similar geological process, in order to recycle minerals and nutrients through the crust, and to create diverse habitats and topography, and would have a moon between 1% and 10% of its size orbiting it at a moderate distance. It's not possible to evaluate distant exoplanets on all these criteria. There is no way to calculate an exoplanet's landmass area, for example. No place like home? A planet's carrying capacity for life can surely be raised if we fine-tune the environmental screws, so to speak. We can certainly imagine and perhaps even come up with a formula for a planet more habitable than Earth, a superhabitable world. But I suspect Earth is very close to the optimum, as evidenced by our rich global biosphere. As we venture into space, we may discover that there is in fact no place like home. If you enjoyed this video, please like it and subscribe to the channel. And don't forget to watch the other videos we made for you. Thank you.